Hello everyone. Today we will study oxidation-reduction reactions and we'll do some experiments. First experiment is a reaction metals, for example zinc, experiment A, with hydrochloric acid. This one is diluted solution of hydrochloric acid. I take some amount and look at the tube, I can see a small amount of bubbles. I think you don't see these bubbles because it's a very, very small amount. But if we heat it by using electronic heater, reaction speed will increase, and you can see more of hydrogen hydroxide gas. See these bubbles in the tubes, and piece of zinc coated with these bubbles of hydrogen. Next reaction. If we put some pieces of iron on the tube and add solution of copper salt, for example copper sulfate, iron will react with copper, but we will not see the result of this experiment. Let's put it to a tube stand, and we will return to this experiment later. Let's do our experiment. At the end of our lab, we will return to this experiment. Next experiment is a reaction between hydrogen peroxide and iron 2 salt. This is iron sulfate. Also, we should add sulfuric acid. Because sulfuric acid is a condition of this reaction, solution of sulfuric acid. And then we will add hydrogen peroxide. I will use hydrogen peroxide from the pharmacy, from the drugstore. And then when I add, you will see the change of color from colorless to light yellow. Light yellow. It's the color of iron 3 sulfate solution. Next experiment also will use hydrogen peroxide, but this time in reaction with potassium iodide. Also, we should add sulfuric acid like condition. And then we will add a few drops of hydrogen peroxide. The orange or red color indicate the formation of molecular iodine after oxidation of potassium iodide. Next one, the reaction between iron 2 salts and potassium bichromate as oxidant. Also in acid environment, so we will use solution of sulfuric acid. And then we will add potassium bichromate. Color will change to dark brown. Color is a mixture of the color of mixture of solutions of iron 3 salt sulfate and chromium sulfate. Next reaction. Now we will use potassium bichromate to oxidize iodide. Sulfuric acid as a condition and potassium bichromate solution. Also, you can see red color, also because of formation of molecular iodine. Next reaction is more interesting. We already used today hydrogen peroxide as an oxidant, but hydrogen peroxide can be a reductant if we will use more strongest oxidants. For example, potassium permanganate. If I will add potassium permanganate to this solution, potassium permanganate become colorless. If I add more hydrogen peroxide, this solution become completely colorless. Particularly colorless. We don't react immediately, and we can see small amount of gases because oxygen gas is a product of this reaction. So, completely colorless solution. Another reaction with potassium permanganate. Potassium permanganate is a very strong oxidant, and it also can oxidize chlorides to chlorine. But in this case, I will use more concentrated sulfuric acid. You should be careful. And if I add a solution of sodium chloride, rock salt, you can see color become colorless. I can repeat this experiment. I add more potassium permanganate, and immediately become colorless. If I add more sodium chloride, also sulfuric acid, without any additional amount of reagents. And the last experiment, reaction between potassium permanganate and sodium nitrate. Also in acidic condition. Look, this solution is purple colored, and then I add sodium nitrate. Color become colorless. That's all. Please write all equations, and if you will have any questions, please ask me. I promised you to let you see the result of experiment B between copper sulfate and iron pieces. It's reactions not so fast, so we waited several minutes, and then I don't know you can see or not, pieces become red colored because of formation of metallic copper. These pieces was dark colored as pieces of iron, but become slightly red colored because now they coated with metallic copper.